before we construct perpendicular bisectors, we probably should make sure we remember what they are. We know what perpendicular means. We know what a bisector means. It divides something equally in half. So a bisector that is perpendicular could be a line or segment that's passing through that midpoint of a segment, forming a right angle. So it has to have both. So here's a few examples of lines L, M, and N, all bisecting because the two sides are congruent, but it's not perpendicular. Here we have three lines that are perpendicular, but we don't know anything about bisecting, so we can't assume that. And finally, down here, line L is both the perpendicular and the bisector of AB. So I'm going to make sure you have both, and it's easy to do with constructions. So let's start by constructing the perpendicular bisector of CD. You want to use your construction tools. Move that down a little bit. I am going to move my compass so the point is on one end of the segment. And I'm going to open it up to just visually a little more than halfway. So just by my estimate, I want to go a little more than halfway. That looks pretty good. And I'm going to make an arc below and above. So I could complete it and make the whole circle, but I think that's about all I'm going to need. I'm going to move the point over to the other endpoint as accurately as I can. I'm going to keep that same compass opening, and you can see where I could easily make 2 points of intersection. So I need one here, and I need one down below, so I'm just going to make a big arc. I have 2 points of intersection now that I'm going to connect with my straight edge. And we should be able to see this is a perpendicular bisector. Of CD. You can measure it with your ruler if you'd like, but you can see that the radii of the circles are the same. Here you see a partial construction of perpendicular bisector. I'm going to go ahead and add the actual bisector here by using those points of intersection. And we didn't line up real well, so I'll try that again. It's pretty good. The pencil paper is probably a lot better than using the computer. But you can see that it has bisected it because you can see the radii of the circles, and you can see that this would be a right angle, so it's perpendicular. Imagine a point that is on the perpendicular bisector and kind of think about the distances. And I'm just going to sketch the distance from a point on the perpendicular bisector to the end here, and a point on this perpendicular bisector to this end point. And it should make it clear to you that these two distances are the same because you use the same compass opening. And so we can say that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. The converse of that, if we remember, is when you switch the hypothesis and conclusion. So I'll take the part after the then and kind of clean it up a little bit. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. And kind of think about it, even as you make a sketch using the construction above. If you knew that there was a point the same distance from these 2 points, it would have to be on the perpendicular bisector. So even if it's not physically on your line that you see, you could extend that down and you have some congruent triangles there that you're drawing. Now would be a good time to go ahead and practice drawing a perpendicular bisector of a segment below on your paper where you have room. Since we know how to construct a perpendicular bisector, we can do a few extra things within triangles, and so we need to define those. The first one's called the median, and as you can see from the drawing, it's the segment that connects the midpoint to the opposite vertex. So let's go ahead and fill that in, a segment joining a vertex of a triangle to the midpoint of the opposite side. And another one would be a mid-segment, and notice that you have a midpoint, and you have another midpoint down here. And so the segment that joins those two midpoints is called a mid-segment. Segment joining the two midpoints of the triangle. So for our last construction, let's go ahead and construct the median of triangle ABC and the mid-segment of triangle DEF. So for the median, as we know from looking back at our definition, we simply need to find the midpoint of one of the sides. So choose a side that looks nice to work with here. I'm going to make this compass a little bit smaller and turn it. And I'm going to follow the rules for a perpendicular bisector. Open my compass a little more than halfway, just visually, a little bit more than halfway. And if I don't, I can go back and fix that, and that will probably happen at some point. And I just want these two to overlap. So if yours aren't overlapping, you need to go make your compass a little bigger and start over. I'll use my straight edge tool, and I have to use mine, but you could almost line up your ruler and only find the midpoint, because all we really needed, I'll use a different color, is the midpoint right here. So now I can use my straight edge tool again to connect the midpoint. Even though I found the perpendicular bisector, I just need the midpoint to the opposite side. So let's call this point M, since it's not on here yet, and we can say that MB is a median of triangle ABC. So that's great for an example. And our last construction is to find a mid-segment of triangle DEF. So I'm going to find the midpoint of two sides, and it doesn't really matter which two because it was just practice drawing the mid-segment. So I'll do side DF and DE. Again, just a repeat of that construction, open a little bit more than halfway, and I will make my arc. And do the same thing at angle D. I want to keep that measurement the same. Make my arc. Use my straight edge tool to connect. And all I really needed from this, even though I got a perpendicular bisector, all I really needed was the midpoint, and I'll do the same thing to DF. That measurement didn't have to be the same, but it just kind of worked on my triangle. You can change it as long as these two at the two ends remain the same. All right, so now mine is a little too small. So I'm going to go back and erase the arc that I made, which you might need to do that too. And I'm just going to open it a little bit wider. Make an arc. I know I had to go a little bit wider because it almost touched, I believe. And I will make an arc from here. And I'll use my straight edge tool to connect them. Again, you can just line up your ruler, marking the midpoint only, because that's all I need is this midpoint, and I will connect midpoint to midpoint with my straight edge, and I've created a mid-segment. So this is triangle DEF. I've used M and A's and B's. Let's see. Let's call this G and H. So I can say that GH is a mid-segment of triangle DEF.